Hello guys, in today's video we'll be solving this very interesting question, which is to find the duplicate number in an array. And I will be like, how is it so easy a question? But then no, it is. Reason being, because of you not should not use any extra space. Yep, you can use maybe two iterations, three iterations, or whatever you want to, but then you should not use this extra space. That is, you should not use the concept of mapping, hashing, or whatever, like anything that lets you store the index of, or let's say the existence of one number in an array. So that is what makes this question a very nicer question. But then the approach that I'll be using in this question is slightly related to what we have done in the linked list section. That is, we have solved this question, that is linked list cycle. Now, how do we do this? What we do is we'll start with two pointers, right? And we'll keep on moving, like the slow pointer and the fast pointer. Slow pointer will move one step, fast pointer will move two steps. And at any point in time when the slow pointer becomes equal to the fast pointer, we'll know that there contains a cycle, right? Because no matter how long a linked list is, if you are having two pointers, that is both of them in which one pointer is twice the speed of the other, every pointer will reach every like both the pointers will reach all the other nodes, right? The only difference will be in the fact that since one pointer is slow, it will take twice the time of this particular pointer, but then at the end it will, by then this would have come here back, so it will pakka coincide, and there is a mathematical proof to it. I don't have pen tablet to explain you that, but then there's a very good mathematical proof in which what we do is we take a circle and then we'll see, okay, if we are starting from the this point, this particular point, like the left equator point, let's say in the 50% time we'll cover this, right, the fast pointer, and by then the slow pointer would have covered only till this much. Then another 50% time it would have come here, right, and slow pointer would have again come here, right? So in twice the time both will intersect. Similarly for this node, so it will pakka, it is pakka that they will intersect. So that is how the approach of this is. We'll first solve this question and we'll similarly like replicate the same approach in the other question that we have seen. This is linked list based question and that is an array based. So let us start by taking this list node star slow ptr is equal to what, head. And yeah, this is my convention of taking both of them as head. There are people who take fast pointer as the next pointer to the head, but then to manage the case when we have, I mean, for my sake basically we can manage both the cases in both either of the ways, but then for my sake I will, while fast ptr next is not equal to null, and we'll first check fast ptr. Fast ptr is not equal to null, and fast ptr next is not equal to null. What we'll do is we'll push slow ptr next, fast ptr, fast ptr next, because since it is fast we'll have to run it for twice as much as we run the slow pointer, and then till when the slow pointer is not is equal to the fast pointer, if not while, because this while loop is this one, right? So till it becomes null will run, and if slow pointer is equal to fast ptr will return true. And by the time when let's say there is no cycle yet, see if there is no cycle, there will, see if there is a cycle, then it will keep on rotating in that particular cycle. It won't reach null pakka. And if that is the case, then the only thing that terminates the loop or terminates the program is this condition, that slow pointer is equal to return to will return to. And in case there is no cycle, there won't be any loop, right? So what will they'll do is they'll you know end traversing, like they'll at some point in time end the traversal of the linked list, right? There will be a point where we end the traversal of the link, and in that case we'll return false because we have ended the traversal and we didn't find any cycle. So I guess this should work. It's very simple code, and let us submit this. find this is accepted and we'll replicate the exact same methodology here, in which what we'll do is int slow is equal to nums of 0, like the head thing. In fast is equal to nums of 0, so the head thing. What we did in that question, we did do, like we had a loop, right? So here also we'll have will instead of do while loop. So do till when? While slow is not equal to fast. Because here it is said that the duplicate number exists, right? So there won't be a case when we are stuck into an infinite loop. So we'll do this. Slow is equal to nums of slow, and fast is equal to nums of fast. So yeah, and yes, this should be it. And wait, once we have to find the duplicate number in this case. So we'll have this. This is to detect a cycle. Now we know that, okay, fine, slow and fast pointer is standing at that particular position. Now what happens when they are standing at a particular? This only proves that this graph has a cycle. So by this only proves that this has a duplicate element. Now what we'll do is we'll keep one pointer there itself. We'll, let's say, move the fast pointer, we'll keep it there only, and then what we'll do, slow is equal to nums of 0. We'll bring the slow back to the head, and then while slow is not equal to fast, slow is equal to nums of slow, and fast now also is equal to nums. So both are taking one step. There is another, again, there is a mathematical proof to it which I cannot explain right now since I'm not having this pen tab thing, but yeah, that is what it is. Like, if we have this, I mean, if you take a pen and paper and start traversing, you'll understand that once in a loop I found a point, like that will not always be the point which marks to the what do you say, the element that is repeating. No, if it has a loop, then at any index both of them becomes equal at any index, not necessarily the index which is forming the loop. So after we found the point wherein both are intersecting, we'll take one pointer from here and keep that to the start, and then this also will my one step, 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 one step. So by the time it reaches this, it also reaches this. So that is how we find, not this, any, the by the point this both intersects each other, and that point is the point wherein, and which is the cause of the loop. So here that is the duplicate element in this case. So now since both of them are pointing to that particular duplicate, we can either return slow or fast. So we'll return slow and then push this. I mean, run this. And slow is not equal to fast. Okay, yeah. Semicolon. We can do it this way as well if we want to. Instead of do while loop, we can have this while loop. Oh yeah, we cannot. So, so yeah, we'll submit this code. Yep, it is accepted solution. That is all for this video. Until next time, thank you.